Hopefully. All right, now with 100% less echo. Hello and welcome to the reading group, which I don't know is actually happening. I mean, it's happening. I'm here. I just don't know if the stream is going. Hopefully today we will not have internet problems, but we'll find out. And I don't have the chat up either. Sorry, it is meeting time o'clock. So I am live. Fantastic. That's exactly what I'm looking for. Hello, everybody. Good morning. It's morning for me. Let's start this paper. So the paper today is a new one. It was from EMNLP, Empirical Methods in Natural Language Processing. Should be down here. Yeah. EMNLP 2020. Which is one of the ACL conferences. I've mentioned it before, but if you're unfamiliar, the Association for Computational Linguistics is the big, what's the word I'm looking for? Professional organization for computational linguists and folks working in an NLP. And it was from last year. And the paper is about evaluating conversational dialogue systems. So this is something that, I mean, obviously we think about a lot. Ooh, get that out of the shot. Just tuck that away. We think a lot about here at Rasa, some ways that we evaluate systems. I think conversational dialogue systems are slightly different from task-based dialogue systems, but there hopefully will be some overlap and some good information here. Metrics that we use tests to make sure that the system is following exactly the conversation templates we want. Hi, Nick, or Neek. Welcome. We use model evaluation to see sort of how good we are at guessing intents. We use so for systems that are in deployment, how often can people resolve their problems within the assistant, and how often do they need to ask other people for help? And the more they need to ask other people for help, there we go. I can have a whole nother shoulder. Look at that. The more they need to ask other people for help, the more expensive it is for the company, and the more frustrating it is. So that's a measure that we use as well. But obviously not the only measures, and maybe that's not obvious. There's lots of ways that you can measure conversational assistance. So let's see what these folks are recommending. And it is by a lot of folks, all based in Europe. And I'm not going to read their names because I'm just not going to do them justice. But these are the co-authors. The first author is Jan, maybe? Jan Deriu? Switzerland. That does not narrow it down a whole bunch. So let's start reading. Why did I specifically choose this research paper? Rasa already has evaluation methods. We do. And the paper is quite a complex study. That's a great question. One of the... Yes, we have evaluation methods. As are, so things like we're using like for evaluation for things like intents, right? We're kind of moving away from intents. And how do you evaluate a system when you no longer have that categorical classification stage in the middle, which is used primarily because it is easy to evaluate, right? It's easy to tell, from a machine learning standpoint, it's easy to design your loss if you're like, did I sort it into the right group or not? A little bit harder to evaluate once you start to move completely away from intents. And also, I think it's important to think about, systems not just as a bunch of machine learning bits that you've stuck together like Legos, but also how well does this work in situ? And and also I think evaluation is a really fertile area right now in NLP in general because of the renewed interest in generative language stuff, so NLG, natural language generation. And a lot of the methods for evaluation there are taken from the machine translation literature and are not great fits. So Blue Score you'll see used a lot. I actually have a huge blog post I wrote about why blue is not ideal as a score for most things. Let me see. Yeah. So it's, if you're interested in reading my very lengthy thoughts on it, it's a 17-minute read. I wrote a big blog post on blue and its limitations, and basically it's a corpus measure, and if you don't have two corpora that you're trying to see how parallel they are to each other, more or less, it's not the right choice, to summarize. So, good questions. I also just thought it looked interesting. Abstract. Oh, the other thing, sorry, I didn't mention the other thing. So, things that work well, great. Also, efficient is really important if you have a really large system that's being run a lot and you want to make sure it's doing good. So, the lack of time-efficient and reliable evaluation methods hamper the development of conversational dialogue systems, chatbots. Evaluations requiring humans to converse with chatbots are time and cost-intensive, place high cognitive demands on the human judges, and yield low quality results. So here they're talking specifically about things like chatbots, and the evaluation method is like, how many turns is a person willing to work on it, or are they doing like a they're adding information to each turn, like how bot-like is this? In this work, we introduce Spot the Bot, a cost-efficient and robust evaluation framework that replaces human-bot conversations with conversations between bots. Human judges then only annotate for each entity in a conversation whether they think it's human or not, assuming there are human participants in these conversations. Also, I'm really interested to see how this goes, because this can be fraught. I'll put it that way. Yeah, people use blue. People use, there's a bunch of other methods that people use as well. Rouge, I've seen a lot recently. But yeah. It's, I don't know. I understand technically why you want a one single numeric score that says how good it is and that you can make go up or down as necessary over time. But as it turns out, human language is very complex. And reducing it to a single number may not be the best way of judging your system. Okay, so this is, you know, sort of classic Chinese room Turing testy sort of stuff. Do you think this is an automaton or a human? These annotations, actually, are automatons clockwork definitionally? Automatons may have to be clockwork. These annotations then allow us to rank chatbots regarding their ability to mimic the conversational behavior of humans. I mean, open question as to how much that is the thing that you want chatbots to do. Since we expect all bots are eventually recognized as such, we incorporate a metric that measures which chatbot can uphold human-like behavior the longest, i.e. survival analysis. Oh, interesting. I think this is the first time I've seen survival analysis in an NLP paper. It's usually used for like populations over time. And then like the metric is like, you know, by age 120, all humans are dead. I actually don't know how old the oldest human is. By age 150, all humans are dead. At age 0, most humans are alive. And then you sort of like draw a curve over time for a population. Since this metric has the ability to correlate a bot's performance to certain of its characteristics, e.g. fluency or sensibleness, yielding interpretable results. The comparatively low cost of our framework allows for frequent evaluations of chatbots during their evaluation cycle. We empirically validate our claims by applying Spot the Bot to 3 domains, evaluating several state-of-the-art chatbots, and drawing comparisons to related work. The framework is released as a ready-to-use tool. So a couple of things. A, they're looking at how good the bot is at being human-like. And I think it's an open question as to in what situations that is actually good and helpful. And they are also judging it like how well it can fool humans. Again, I think it's an open question to what degree that is good and helpful. Evaluation is a long-standing issue in developing conversational dialogue systems, i.e. chatbots. The underlying difficulty in evaluation lies in the problem's open-ended nature, as chatbots do not solve a clearly defined task whose success can be measured in relation to an a priori defined ground truth. So here, the difference between a chatbot and a task-oriented dialogue system, which is usually what people are building with Rasa, is that a task-oriented dialogue system, you can judge, did people do the task? A chatbot is judging like how good it is at having conversation. So the technical name of that task is chit-chat, C-H-I-T-C-H-A-T. Automatic metrics have so far failed to show high correlation with human evaluations. Human evaluation approaches are mainly classified according to the following: single-turn versus multi-turn evaluation, and direct user evaluation versus expert judge evaluation. Single-turn analysis is usually performed by a human judge that rates a single response of the bot to a given context, whereas multi-turn analysis is often performed by a user that interacts with the bot and rates the interaction. Single-turn ratings disregard the multi-turn nature of a dialogue. You can have single-turn dialogues. Although more and more multi-turn evaluations are performed, most of them are based on human-bot conversations, which are costly to obtain and tend to suffer from low quality. The instructions to be followed by annotators are often chosen ad hoc, and there are no unified definitions. So here I think they're talking about sort of crowdsource workers who are often, have strong time pressures and are really trying to make enough money to live on, so are not always very slow and careful in a task. Compounded with the use of often criticized Likert scales, these evaluations often yield a low agreement. The required time and cost and time efforts also inhibit the widespread use of such evaluations, which raises questions on the replicability, robustness, and thus significance of the results. So Likert scale is a 5-point scale. So you've probably used them like rating between 1 and 5 stars, or, do you strongly agree or strongly disagree with the following statements? Or like 0 is neutral, or sorry, 3 is neutral. Wow. And a couple of problems with Likert scales from a behavioral perspective is that people tend to cluster towards the middle of the scale, traditionally at least. So there's a bunch of sort of psychometric work done in the 70s and 80s, I want to say, that found that people tend not to use the end of the scales. They tend to sort of cluster around the middle of the scale. And I would also say that there's probably, again, I'm not super deep in the psychometrics literature, but I would guess that there is now a trend towards rating more things higher because of the way that Likert-like evaluations are used to, rate workers and products, and both sort of the inherent politeness in rating people high, because if you rate them low, they might get fired, and also fraudulent reviews and the way those sort of skew those systems. So just... There are lots of things to know about Likert scales. They're not necessarily inherently a bad research methodology. Low agreement. They're expensive and hard to replicate, which I think makes sense because what makes a conversation good to one person will not necessarily make it good to the other. And I think there's a differing degree to which, just like behaviorally, humans are willing to meet their interlocutor, halfway or more than halfway. So a lot of the stuff we've been talking about with, language generation is that we as humans really want language to be meaningful, so we will do a lot of work, mental work, to make it meaningful. And I think, in conversations, the same thing is the case. We'll do a lot of work to make a conversation seem conversy, dialogue-y. So their suggestion, mostly you have people interact with your assistant and then rate it in various ways. They're suggesting that you have assistants interact with each other and have humans rate those interactions. So the conversation having part has now been moved away from humans. In this work, we present the Spot the Bot framework, a cost-efficient evaluation methodology that can be used to rank several bots Oh, what they're saying is that with this methodology, if you have several bots, you can rank them with regard to each other. I read this as being our methodology can only be used on a small selection of bots out of the whole population of bots, and the rest of the population of bots can never be evaluated in this way. Scope ambiguity. What were we talking about? Several bots. It works as a multi-turn based evaluation with human judges. Spot the bot is based on two observations. First, chatbots are trained on conversations between humans, and thus they should be evaluated regarding their ability to mimic human behavior. Second, the longer a conversation is, the more likely it is that a bot exhibits non-human behavior. Yeah, so again, we're talking about chit-chat here. We're not talking about task-oriented dialogue. And I mean, chit-chat is something that we can handle in Rasa, usually using some sort of retrieval intent. Yeah, two things that pop out to me right here is that a lot of chatbots, even chit-chat bots, are not trained on conversations between humans. They are trained on conversations, you know, between humans and assistants. They're trained on so in the Rasa context, almost all of your training data is going to come from human assistant conversations rather than human-human conversations. And I think you can have an assistant that mimics human behavior really well, that is not very useful. And you can have an assistant that doesn't mimic human behavior particularly well, but is also very useful. So just thinking about like voice systems that I've used in the past, some of the ones that are the most helpful are the ones where you can just like, you're familiar with the system, you've used it once or twice, and like as soon as the voice prompt starts, you're like 5, 6, talk to Jimmy, or whatever the prompts are. Yeah, interesting. I think this is a big claim that they are making, and I'm sure they will support it. The longer a conversation is, the more likely it is that a bot exhibits non-human-like behavior. Here, I would agree. Even with, you know, state-of-the-art conversational systems, they're not really... Chit-chat is obviously a different task, but for dialogue systems that are more task-oriented, you're probably going to, like, get the same response a couple times. If you're going through a long conversation, you're probably going to... you'll run into something where you're like, this is... I mean, you should be able to ask and get the information back, but you'll probably run into something. So I think this is less problematic of a statement. I don't think it's problematic. I just think that like they're going to need to justify this first observation. Although because they say it's an observation, I'm thinking that they might not. We'll find out. Spot the bot works by generating conversations between bots, then mixing these bot-bot conversations with human-human conversations and letting... Oh, so there are no human-bot conversations. But I don't think the participants are told that. Ooh, interesting. Human-human conversations, presumably from the chit-chat training datasets, and letting human judges decide for each entity in the conversation if it is a human or a bot. I'm sure they'll talk about this, but... Interesting. Like, if I were doing this, I would use the conversations from the training data set and then also the bots trained on the training data set. So yeah, in that case, mimicry is a good metric because you want to be able to capture the underlying patterns in the human-human conversations. The conversations are rated at different points in time, which introduces a time-dependent component. So I think this is the survival analysis that they mentioned, because the survival analysis is how does something that's eventually going to go to 0 change over time. This setting, no, I think there is a strong assumption that it's bounded by 0 for survival analysis. It's been a while since I've done them, but I'm pretty sure. This setting allows for 2 different analyses, a ranking based on pairwise comparison of bots, and the application of a survival analysis, which computes the survival rate for each bot at different conversation lengths. Furthermore, the human judges annotate the entities with respect to more fine-grained features, which can be chosen based on characteristics that the bots are expected to exhibit, e.g. fluency or informativeness. The survival analysis further allows us to pin down the features that contribute to a dialogue system survival, enabling interpretable results. Interesting. So just thinking, I mean, they'll talk about this in more detail, but just thinking about this, this methodology, it is an easier task to rate something than it is to produce open-ended text. I mean, you can even think about, like, what can we automate easily? Rating a string of text based on some characteristic is an easier task than generating well-formed human language, right? So I think making the tasks simpler for the raters is absolutely very useful. Yeah, I think that's all I have to say there. We show that our framework produces reliable, repeatable results. Well, on the other hand, sorry, so going back to this, on the other hand, it is easier for the raters, which means you're going to get more ratings, which means you're going to get more data, which means you can get more people to do it, all of which are good. On the other hand, rating conversations for human likeness, again, this is chit chat, so it's a different task than a task-oriented dialogue system. Like, that's not a direct measure of how good the system is to use, right? So it is rating human likeness, yeah? And the assumption is that human likeness is the ideal, and that a system that is human-like is also going to be good to use, which, yeah, no, I'm back on board my train where I want them to justify that. All right. We show that our framework produces reliable, repeatable results while being quicker and more cost-effective to run than related approaches, as it does not rely on human-bot conversations and generally requires fewer annotations. Oh. I was assuming they were going to get more annotations. Furthermore, we show that disagreement between human annotators can be interpreted as a feature of the system's performance rather than a weakness in the evaluation approach. We apply the framework to 3 well-known domains and common baselines, state-of-the-art systems, blah, blah, blah. You can use it. So if you're using human raters, a really common way to judge the quality of those ratings is to use a measure of agreement between raters. So IRR, inter-rater reliability is a really common one. And they're suggesting here that they're not getting a lot of agreement, but that actually that's good. And I'm pretty sure in this section they were like, there's I'm pretty sure up here they were talking about low quality, ad hoc. Yeah. So here they're talking about lack of agreement as a problem with the current evaluation metrics. But here they're saying, actually, for us, lack of agreement is fine and good. I am not going to be super on board with that unless they do adjustment for individuals. So for different people, right, you can imagine that different folks are going to be more liable to believe that somebody is a human than other people. And what you want is for your system to be more reliably human than, like, some imaginary baseline, right? So you are rating within an annotator and not across annotators. And I think here they might be treating these ratings as some sort of, like, we'll see. We'll see. My behavioral experimental training is going, All right. There exist various methods to evaluate dialogue system, both automatic and human-based, but no single evaluation metric is widely agreed upon in the scientific community. This is absolutely true, which is part of the reason why I think this paper is interesting, because it offers a new approach. Automatic evaluation metrics for chatbots are likely to correlate poorly with human ratings. So we focus on human-based approaches, Yeah, absolutely. Which can be classified into two dimensions, single turn, multi-turn, and approaches where dialogue systems are judged by the user directly, interactive, or where judgments are made by objective experts who did not participate in the dialogue, static. Okay. Oh, and here's the code for the system if you're interested in checking it out. Single turn static evaluations. I think I'm just going to sort of skim through these rather than reading them through. No, I think this is helpful. Evaluations based on the static context and a single response from the dialogue system are widely adopted. So these are, really easy to generate, really easy to just send people a huge batch of them to rate. Usually, the rating is performed by expert raters that read the response of one or more dialogue systems to a static content and rate the responses. Alternatively, the response of two bots can be compared directly to choose the preferred answer. And this is, the fewer choices somebody has to make, the quicker they can do the task, the easier it'll be for them. While being relatively time and cost efficient, single-turn evaluation fails to capture the conversation's quality as a whole. A system that tends to produce repeated answers can obtain a high single-turn score, albeit a low multi-turn one. So I think a good example of this would be like an assistant that always says like, "Oh, hey, that's cool," which as a response to one thing that you say is like nice and convivial, and as a response to everything that you say is not great communication. Some authors also report poor inter-annotator agreement. Yeah. I'm really interested to see how they're going to position their poor inter-annotator agreement as a benefit as opposed to these poor inter-annotator agreement, which are obviously bad. I would say, I don't know that they're... I will say this, I don't know that it is inherently bad to have variation between judgments. I will say that what I take that as someone with a lot of behavioral training and also someone who works in machine learning, is that it is a complex task, right? If there is no immediate agreement about what the rating should be, and it's very robust across people who have similar degrees of experience with whatever it is, I would say that it is easy to read Chinese if you read Chinese. I don't read Chinese, so if you asked me to read Chinese, I would do badly at it. I could recognize maybe 4 characters. I've taken a lot of years of Chinese, but I can recognize maybe 4 characters. But if you had a number of people who were literate in Chinese, they would probably have pretty high agreement with what a word is, if not necessarily how it's pronounced, but the underlying understanding of the semantics would probably be pretty resilient across that group. Whereas sort of judging the quality of a poem is probably going to be, much more varied because that's just inherently more complex. Low inter-rater reliability, low inter-annotator agreement does not necessarily mean that a method of evaluation is bad. It's probably just signal that the thing that you're trying to do is really hard. This has been Experimental Methodology with me, Rachel. All right, human-bot conversations. In order to perform interactive multi-turn evaluations, the standard method is to let humans converse with the chatbot and rate it afterward, typically using Likert Scales. The Conversational challenge, I'm pretty sure this is out of the Allen Institute for Artificial Intelligence. My brain finished that acronym as Architectural Identity, which is not the words that go in there. Good job, brain. And the Alexa Prize applied this procedure. Apart from the high cost of collecting human-bot conversations, this approach puts a high cognitive strain on humans as they have to perform several tasks at once. That's fair. Besides, it is not always possible to get sensible conversations with bots, making it hard to get high-quality conversations. I mean, that's Signal too. In fact, in the Conversational challenge, half of the collected human-bot conversations were discarded due to low quality. Same first author. Finally, Likert scales are known to suffer from high annotation variance, require normalization a posteriori. So you have to posteriori. After the fact, you have to go through and normalize the scores, which is, I think that's very normal. I don't think that that is a negative. And are prone to order effects and are less reliable than ranking-based ratings. So order effects is if you start with something really good and someone's default answer is a 3 and they answer 3 on the first one, and all of the rest of the items are worse than that one, you're going to get a lot of 1s and 2s. If you start with something really bad and someone says 3 for the first one, you're going to get a lot of 4s and 5s because all the rest are better than them. So that's an extreme example of an order effect. And are less reliable than ranking-based ratings. So you tend to get more variance in the answers. Recently, I can zoom in a little bit more, using self-talk dialogues, i.e. dialogues, I cannot zoom in anymore. Okay. Yeah, that'll work. There we go. One too many. There we go. Recently, using self-talk dialogues, i.e. dialogues where a bot talks to itself, gained traction as a cost-effective basis for evaluation. Sorry. Sorry, so the face I'm making now is that I had a different vowel in this talk and as in this talk. Why? Is it vowel harmony with bot? Am I assimilating to Seattle vowels? Oh no. Sorry, so I have digression. I have 2 low back vowels, which is common in the South. Most people in Canada or the West or the North of the United States have a single vowel. It's known as the low back merger. So I have a difference between ah and aw. Those are 2 different vowels for me, also called the quat merger. I had a different vowel in each of these talks when I said it. Talk, 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 ah. Yeah, I think my usual vowel is ah, and I think this one became aw because of assimilation or perseveration to this bot vowel, which is definitely aw. I don't have any coffee right now. I have had less than my usual amount of coffee, so please excuse the identity crisis about my vowels. Anyway, so the bot talks to itself. You can use that for evaluation. Downside, it tends to get very weird and it is not especially human-like, almost always. The idea is closely related to user stimulations used to evaluate task-oriented systems. Gandaharuin? Apologies if I'm saying that incorrectly. Et al. 2019, and Deriu and Cieliebak, perhaps, use self-talk to produce automatic evaluations. I haven't read these papers, but my general impression of the state of self-talk evaluations is that, again, they tend to get weird, and that if you train a system using self-talk evaluations as like your loss metric, you tend to end up with very degenerate results, so bots that really do not sound like humans at all. In Acute Eval, the authors propose to let humans evaluate self-talk dialogues. Since self-talk does not allow direct comparison between bots, the authors let humans read 2 self-talk conversations side by side and rate them with respect to various features. This increases the cognitive complexity of the annotation task. Furthermore, the resulting ranking of the bots is per criterion, whereas our method produces 1 ranking and can optionally incorporate annotations of features that yield interpretability of their results. So they're saying that for each of the responses, you get a rating. With their method, you're going to get 1 rating for every bot, not 1 rating per turn per bot. And you can add feature annotations to increase interpretability. Turing test. Spot the bot is reminiscent of the Turing test. Yes, as the dialogue systems are evaluated based on their ability to mimic human behavior. The Turing test served as a useful mental model for understanding what machine intelligence might mean. However, it has also been criticized as a way to identify intelligence in NLP systems. Bender and Kohler, so this is the octopus paper that we read a while ago. CBBNWX says, how do you choose what papers to read? I have a big spreadsheet. I put in papers as I come across them, and then when it is time, I look at the titles and look over the abstracts and decide which one I am most interested in on a given day. That's the full answer. Also, I'll sometimes flip through them, and if it's just like an algorithm paper and it doesn't make a super big contribution, usually I won't choose that one, just because I don't think they're as fun to read. Bender and Kohler argue that a system, I think here it's argues because this is being used as a reference to a single paper and not referring to each of the authors. That a system may fool a user into believing it is human, and yet this does not prove that the system understands the meaning of the conversation they are having. In our approach, we claim that failing the test is a valid indicator to discriminate among bots. In fact, we presume that eventually all bots will fail the test, and we can collect a time component to record the time it takes for a bot to be detected. Yeah, I think that is Signal. You know what? I buy this point. So their point is that passing the Turing test does not mean that you have natural language understanding, but failing the Turing test does mean that you failed to be human-like, and they're trying to see how long it takes a system to fail. My one critique here is that given, tests like the acute eval, we know that bots are going to be differently good at different inputs. So it makes sense that depending on the input, one system may fail the test earlier than the other, and that is not necessarily an inherent measure of the robustness and reliability of the system. It's a measure of the order effect to which it's an order effect of the conversation, right? Does that make sense? So if my bot can only talk about cats and the first question is about dogs, my bot's going to fail right away. If my bot can only talk about cats and the first question is about cats, it's probably going to keep that, conversation going for quite a while. Yeah, but I would agree. I would also want to see more experimental evidence on how easy it is to... I feel like this is a paper that I just don't know, but I feel like I would want to see more experimental evidence on how easy it is to trick people into thinking that human-human conversations are human-bot conversations. But I know that they are going to talk about human-human dialogues in here as well, so perhaps they will discuss it. Spot the bot. In this section, we first provide an overview of the Spot the Bot framework, and then describe the evaluation process's individual steps. Spot the bot. So I don't know if you can tell that spot and bot have different vowels for me, so ah, 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 ah. If I switch them, it would be spot the bot, which sounds deeply weird to me. But my talk vowel is less stable. Employs a tournament among chatbots to determine which performs the best at mimicking humans' conversational behavior. To measure the success of each bot, I don't know what it's about. Is it mimicking? Because presumably these are novel prompts, right? I guess it's a behavior mimicking. I don't know that I would have phrased this way, but maybe I would have. I don't know. To measure the success of each bot, human crowd workers are shown conversation between two competing bots at the time, mixed with conversations between two humans. The crowd worker's task is to determine for each entity... hi, Q. I'm glad you're enjoying it. In a conversation, whether it is a human or a bot, or whether the crowd worker is unsure. The bot that is most frequently annotated as being human wins the tournament. Figure 1 provides an overview of the process for one conversation. So, Figure 1. Yeah, it's big enough. Bot conversations, segmentation, annotation, evaluation. So, I want to try some Chinese dishes. Let me try. You know I like Chinese food. Why do you want to eat something like you? I realize this is a bot conversation, but that feels racist. I'm not sure. You can watch movies too much time. I don't like watching movies. Why don't you go to a movie and eat some food? I don't like Chinese food. You're right. So these are the conversations that they are rating. And I think these lines are attached to the top. So this one, the person was unsure. This person, green, was unsure. This one, nope, this one's attached to the bottom. Where do these lines attach? So this person was unsure about both of these conversations. This one, the person thought the blue was human and the red was a bot. So the blue one won here. This one, the person thought they were both bots, so there was no winner. So these are two ties and one wins. So the evaluation is that the blue bot won one time, and then survival analysis. A bot-bot conversation is segmented into different lengths, e.g. 2, 3, and 5 conversations. This is all one conversation. I've got it. Okay. So this one here, this is a 2-turn conversation, or 2 exchanges. So this one is these 2, and then these 2. This one is these 3, and then these 3, and this one is all... No. Okay, this is the beginning and this is the end. Got it. I'm finally getting this, so these 2 exchanges are these 2 exchanges, and based on these, the person who is annotating wasn't sure if either of these was a bot. So it could be human, could be bot, unsure for both of them. Based on these 3 exchanges, I probably would have made this like a little filled in triangle just to be a little bit more, less ambiguous. So based on these 3 exchanges, the annotator said, blue is definitely a person, and red is definitely a bot. And then based on all 5 exchanges, the person was like, no, that's definitely a bot. So, at the 2 turn, blue was like, maybe it's a bot. At 3 turns, blue was like, oh, yeah, that's definitely human. And at 5 turns, the annotator was like, no, that's a bot. So it survived to 2 turns. It survived to 3 turns. It did not survive to 5 turns. For red, it survived to 2 turns because they were unsure, so they weren't sure it was a bot, and it did not survive to 3 exchanges, and it did not survive to 5 exchanges, and also it lost once, so it was judged to be less human. So this 3 exchange time. Okay. So that's the way that it works. The process is repeated for all conversations between the competing bots. There are different use cases for spot the bot, e.g., when a novel dialogue strategy is to be compared against existing ones, or if a set of chatbots is to be ranked in the context of a shared task. So really, when you have multiple systems you're evaluating is when this is useful. If you just have one system and you're trying to see how good it is, not super helpful, because you need 2 assistants to have conversations with each other. On top of returning a ranking, Spot the Bot employs the survival analysis, which introduces a time aspect into the evaluation and provides insights into how different features correlate to the bot's ability to pass as human. I do like the survival analysis here. Now that I've seen it in practice, I think it makes a lot of sense. Formally, assume a pool of... Is that a beta? I can't tell if that's a beta or just an italicized B. Assume a pool of B bots, B1 through BB, which is to be ranked. We're ranking the pool, we're not ranking the individual bots. For each pair of bots, a set of conversations is sampled by letting the bots talk to each other, where Sij denotes the set of conversations between bot I and bot J. Each conversation is defined as a sequence of exchanges, where each exchange consists of 2 turns. So time stamp 0 at a given exchange, and then timestamp 1 at a given exchange, 1 for each entity. Okay, so it makes sense. It makes sense to me. The more exchanges there are in a conversation, the more likely it is that a bot gets recognized as such. Thus, we show the different segments of the conversation to the crowd workers. A segment is defined as the first K exchanges of the dialogue. Thus, an annotator only sees the first K exchanges of the conversation. Okay, so when they say different segments, all of the segments start in the same place. So like with this one, they all start with turn 1, and then they get turn 2. Some of them get turn 3. Fewer of them get turns 4 and 5 altogether. So these first couple of exchanges are going to be rated more. Ooh. Oh, I'm really feeling like that order effect might come into it. Like the one where I mentioned where if your bot only knows about cats and you ask about cats first, it's going to do really well. If your bot only knows about dogs and you ask about cats first, it's going to do really poorly. Okay, so that could be a latent effect here. Thus, an annotator only sees the first K exchanges of the conversation. We experimented with letting crowd workers decide where they were sure an entity is a bot or a human. However, this approach required too much fine-tuning to constrain erratic annotator behavior. And if you want to check that out, check Appendix B. The annotation procedure worked in 2 steps. First, the annotators have to decide for each entity in a conversation segment if it is a bot or a human. Second, to correlate the outcome various characteristics of a bot, the framework allows ranking specific features, e.g. fluency or appropriateness. The framework then measures the influence of these features on the survival time of the bots, which serve as the explainability component. So fluency is like, how much does this sound like text a human would produce? And appropriateness is, to what degree is this a reasonable response given the input? We chose 3 features: sensibleness, so like, is this a good response? Specificity, does this response directly tie into the thing that you said? So like that example where I'm like, your bot always responds, oh, cool. Might be sensible in a wide range of situations, but it is not very specific. And then fluency, you know, is this believably human-produced text? The first 2 are shown to capture the core conversational behavior of answering sensibly and not with illogical statements while being specific to the conversation's given context. The third feature states if the utterances are grammatically correct and fluent. These features are rated by preference ranking. That is, the annotator states which of the 2 entities performed better with respect to the features. Have we looked at... Oh, we completely skipped this section. Human conversations. We added conversations among humans to the pool of conversations that to be rated. The human conversations are sampled from the training set, used to train the dialogue systems in the respective domain. Called it. It's because getting human data is very expensive and time consuming, so if you already have it, you're probably going to use that. The results of the annotations of the human dialogues establish an upper bound for the evaluation. Also, they are meant to prevent annotators from concluding that all entities are bots. We investigated if annotators realize that conversations are either between bots or humans by looking at the ratios of conversations where both entities are labeled identically, but found no evidence that this happens more often by chance. Okay, so they're saying we're trying to figure out if people know that all the conversations are either bot-bot or human-human. And so we looked at when things were labeled identically, and it didn't happen more often than chance. You want it to happen more often than chance with the human-human conversations, because their argument here is that a good bot is going to be one that can maintain the appearance of being a human. Humans are presumably very good at maintaining the appearance of being a human. I don't think this is like a good thing, right? Like, you'd want the human-human conversations to all be rated human-human. Yeah? Otherwise, you're measuring something, but you're not necessarily measuring how human-like something is, right? If people aren't reliably always rating the humans as human, then the thing that you are measuring is something else. Does that make sense? Hmm. Hmm. We have about 10 minutes left. Yeah, I think I'm just gonna scroll for a bit and see if they talk about this human measure some more. I don't know that we're gonna come back to this paper next week because I got a lot of things I want to read. So I'm just going to sort of skim for a bit. So how they determined the winning, which I think we saw an example of in the figures. So I don't know that we need to go over that. Ranking is generated by true skill based on win rate, and the significant differences in performance are determined by bootstrap sampling. And the result is a ranked set of clusters where each cluster is composed of entities that do not have a significant difference in performance. Okay, so it's like you'll have, you know, the high performing bots, the medium performing bots, the low performing bots. Hio says, maybe I'm a bot now. Maybe. I wouldn't know. I mean, presumably there are protections against automated text being sent in the YouTube chat functionality, but it's a good thing to bring up. Okay, and then they talk about the survival analysis, blah, 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 experiments they used in 3 domains, daily dialogue, empathetic dialogue. Oh, we've looked at this previously. So it's like, are you matching the emotional state of the person you're talking to? Persona chat, I'm not familiar with. Oh, nice. Somebody on this paper is a statistician. I can tell because they're using R. Only 2% of all the sample conversations contain an exchange, which can be found in the training material. Okay, so something that I was wondering about is to what degree the, because these bots are all trained on the same training data, humans are also being shown the human-human training data, so is there some sort of memorization going on? Looks like not. Is there argument here? Nick says, please don't come back this paper. Oh, I think it's cool. I think it's an interesting paper. But yeah, we'll probably do something else. Paid cow workers, Mechanical Turk. We designed a human intelligent task as a batch of 20 conversations, and each worker was only allowed to work 3 batches, so they have a really wide diversity of people who are filling them out. And then they made sure people didn't see the same thing, so that's good. Segment lengths are based on the dialogue. So different data sets have different lengths of dialogue, so they just sort of match that. For each domain, we prepared a pool of dialogue systems to be ranked, and they are sort of using existing systems. So they're using GPT-2 and BERT rank. I believe this model produces multiple utterances and then picks the best one, or given a set of multiple utterances, it picks the best one. I don't remember which one it is. And lots of details here. So looking at fluency, sensitivity, and sensibleness for BERT rank, DR model. What is this S2? We trained a sequence to sequence. Okay. Win rates for each pair of systems. Sorry, what I'm looking for here is human-human numbers. And I do not see it. Right? Unless HF is... Nope. Lost in conversation, hugging face, a blender model. Okay. Feature influence. They're looking at different features. Okay, here we go. So this blue line here at the top, which is a slightly different shade of blue here in the middle than it is over here. So the blue line here is the human rating. Gotcha. And what we see is that the features, survival function for each system. Okay, oh, so this is survival analysis. Okay, so this blue line here is humans. Humans tend to survive pretty well. This one's GPT, the sort of green one here And then some of these overlap, like S2 and BR, and this one down here is DR. And then for this one, blue, and then BL. I don't remember what all these systems are. So what I'm just looking at here is, are the humans doing better? And it looks like they are pretty consistently, and also over time, the human score remains pretty consistent. Although this one for Persona Chat, the survival probability is only 75%. So about a quarter of the human-human dialogues were ranked as not being human-human after the first turn. So just looking at these, I would say the daily dialogue data set, it looks like people are pretty good at identifying human behavior as opposed to bots. For this empathetic dialogues, there's not quite as much separation. And for the Persona Chat, people are not really good at picking out the human-humans either. Interesting. Okay. Checking the time because I have a meeting after this. And then inter-annotator agreement. This is probably going to be the last section that we look at. This is something that I'm really interested in. So this is the agreement on labels, and people don't have a lot of agreement when they label humans as bots, and they have a lot of agreement when they label humans as humans, and then these systems are ranked. So I don't remember what all these abbreviations are, but it looks like there's a pretty big step down to this BL system, and a much smaller step down on terms of agreement when identifying that something is a bot. So interesting. And then unsure has really low agreement at all. And generally, just for like a rule of thumb, in agreement tasks above 60 or so is considered okay agreement. Again, it depends on how difficult the task is. Yeah, given 3 random labels, the chance for random agreement is 0.33. Interesting. Yeah. This analysis suggests that our experiments result do not stem from random agreement between the annotators, i.e. the annotators of the best and worst performing systems show agreement distinctly higher in chance regarding the respective labels. Interesting. So it looks like people are pretty good at identifying bad systems. Well, I shouldn't say bad systems. There are some systems that humans are pretty good at identifying, and also humans are pretty good at identifying humans as humans and tend to agree. So, okay, I think that answers my my big question there. Yeah. And then they're just showing that it is faster. Interesting. So, general thoughts on this. I think that more evaluation techniques in the dialogue space are always welcome. Some of my sort of qualms have been quelled, as it were, about how good people are at identifying human-human conversations. That said, the survival analysis for some of these human-human conversations is pretty low, like lower than I would want it to be, particularly for this Persona Chat task. So yeah, I don't know why that is, but if humans are only, by the time you're looking at 2 turns, a quarter of human-human conversations have been rated as being held by a bot. Maybe that's data set effects, maybe that's something else, but that's pretty surprising, I would say, given that what you're trying to figure out is how good annotators are at identifying when something is a bot. But the author's argument is that given enough time, most artificial systems will be identified as artificial. And you can definitely see that in the survival analysis, humans do better over time and are more stable. So that is good. It's good. I really like the survival analysis. I think that the thing that would be most useful for people working in task-oriented dialogue would actually be to flip it, right? So I usually want my conversations to be very short with an automated system, because conversational AI is great when it saves you time. And there's been a lot of research about like when do people like conversational AI systems, and it's really when they're faster than doing it any other way. So I would want to see in a survival analysis like that the new change that I make, people suddenly are being able to do what they need in 1 turn as opposed to 5 turns. So I think survival analysis to dialogue systems is a cool approach. I think that makes a lot of sense. I do like the sort of inversion of the Turing test where they're trying to figure out who's the bot and not who's the person. I think that I agree that mimicking human language faculty, right, and we've talked about this a lot on the channel, is not the same thing as understanding, but failing to behave human-like probably is good evidence of not being human. So, yeah, interesting paper. Definitely a different way of thinking about evaluation that I really like, and I think it's an interesting approach. I don't know that I would use it, but again, I'm not working in chat. I'm working in task-based dialogue systems, so it is a little bit different. But I think there's some interesting takeaways from this paper. All right, I have more meetings, so I'm going to call it here. Thank you so much for joining me today. I hope this was interesting. I know not, completely the same thing as we do at Rasa, but like I mentioned, I think evaluation techniques are just interesting. And I think overall this was a good paper. I'm glad it got published. I'm glad I read it. Tomorrow, we have live coding, and we're going to be continuing to work in our complex SQL queries. So last week we did sort of data validation and some fuzzy matching to make sure that people don't have to know exactly what's in the database to figure out what's in the database. And this week we'll go through and start working on more complex queries. All right, so I'll see you tomorrow for the live stream. Hope you have a great day. Nick says, see you tomorrow. I'll see you tomorrow. Do we have any data set recommendations? I mean, in general, the best data is going to be your users actually doing the thing. So that's my general data set recommendation for everybody. All right, I'll see y'all tomorrow, same time.